Today we'll look at the principles of conservation of linear momentum. Previously we defined or explained what momentum is all about as the product of mass and its velocity. So the principles of conservation of linear momentum states that in the system of colliding bodies, the momentum before collision is always equal to the momentum after collision, provided no external force acts on the colliding bodies. What it means is that there are two types of collision. We have what we call inelastic collision, and we also have what we call elastic collision. So for the purpose of this class, emphasis will be on inelastic collision. This is a type of collision where the kinetic energy is not always conserved after collision. Let's look at this. We have two bodies, A and B. A moves with an initial velocity UA and B moves with an initial velocity UB. And A has a mass MA and B has a mass MB. So it's if body, for example, body B is stationary, it's not moving, and body B hits this or collide with it, and maybe stick together and move with a common velocity. So the momentum or before collision, their momentum will be MA UA plus MB UB. Then after collision, remember they stick together and move with a common velocity, but their masses still remains. So in this case, after collision, what we have is M2 MA plus MB V. So in this case, we can always calculate their common velocity. But in case where the second body is stationary, it means that the initial velocity will always be zero. So let's look at this problem. A body of mass 4 kg moving with a velocity of 10 meters per second collides with a stationary body of mass 6 kg. If the two bodies move together after collision, calculate their common velocity. So in this case, what we'll do is we'll list the given parameters as mass as M1 is 4 kg, U1 is given as 10 meters per second, M2 is given as 6 kg, and of course U2 is 0 because it collides with a stationary body. So it means the body is at rest, so its initial velocity will be 0. So looking at appealing to this, M1 U1 plus M2 U2 equal to V M1 plus M2. So we substitute. M1 is 4 times 10 plus M2 is 6 times 0 equal to V into 4 plus 6. Now the whole of this will go. So we have 40 equal to V times 10 because 4 plus 6 is 10. And V will be equal to 40 all over 10, which is 4 meters per second.